Hey everyone, welcome to lecture 2.5 on quadratic equations. So today we're going to be focusing on the SLO EQ4, which is I can solve quadratic equations for real and complex roots by factoring, completing the square root property, and the quadratic formula. So in order to tackle this, let's begin by identifying what is and what is not a quadratic equation. So a quadratic equation is actually a polynomial where the highest degree is 2. So polynomials being sums of monomials, so like, for example, x to some power. And our requirement here is that we just have the highest power being 2. So in the first case, we could see that we've got the power of 2 here, and it's the highest. So when we see just an x by itself, we understand the power to be 1. So this one is quadratic. Here, even though not everything is on the same side, it doesn't matter. I still have that the highest power is 2. So this one is quadratic, as is the one directly below it, as is the one to the left. However, these last two, here my highest power is 3. So this is not a quadratic, it's actually a cubic. And in the last example on the bottom right, even though I do have this, which is good, this power of 2, this term here, this is an exponential term. So if this is not a polynomial, and therefore this cannot be a quadratic equation. So quadratic equations are first and foremost polynomials, and then we just have to restrict the degree to 2. So we're going to start with factoring by grouping. And you may have heard of this as the AC method. So when we factor, we want to be able to split it up into 2 separate pieces that can be multiplied together. Typically, we start with the standard form of a quadratic equation, which is ax squared plus bx plus c. And then we're going to go ahead and factor that into 2 pieces. And before we start that factorization process, I just wanted to bring up the zero product property. So the reason we do factorization is because of this right here. So for example, let's say we wanted to factor something, right? If we had, let's say we had x plus 5 and x plus 1. So this would be a factorization for some polynomial, for some quadratic equation. When I have 2 things that multiply to be 0, one of them has to be 0. Like I cannot multiply 2 non-zero terms together and have that produce a 0. So either this is 0 or x plus 1 equals 0. Those are my options. So again, the only way to multiply 2 values together and have their product be 0 is if one of them itself is 0. So we're going to use that when we do factoring to find the solutions to a quadratic. So when we have our quadratic equation in standard form, right? So that's the ax squared plus bx plus c equals 0. We're going to multiply a and c, and then we're also going to just take note of what b is, and we want to find 2 numbers who multiply to ac and who add up to b. So let's just, I think an example is the best place to start. So if I have a standard form, ax squared plus bx plus c equals 0, then I would know that a equals 4, right? So that's the first guy here. I know that B is 15 and C is 9. And a lot of the ways that this is shown, which I actually quite like, is kind of using this diamond method here. So I want to just write out first quickly what A times C is. So A times C is 4 times 9, which gives me 36. So then I'm going to write out in a diamond here, I'm going to write my 36 on top, and then I'm going to write my B on the bottom. So just in general, what we have here is AC and B. And we're trying to find two numbers here. We're trying to find something I can fill out here. I want a number here and another number here where they multiply together to get 36 and they sum up to get 15. So let's look at two numbers that multiply to 36. So obviously I could have 1 and 36, 1 times 36. I could have 2 times 18. I could have 3 times 12. I could have 4 times 9. I couldn't do 5 because 5 doesn't go into 36, but I could have 6 times 6. And 7 also doesn't go into 36, nor does 8. So the next number I would have to jump to is 9. But I already have a 9 here, so this is just going to bring me back down the list. So these are my factors that give me 36. It's all the ways I can write 36 as a product. And now from those, what I want to do is I want to check to see if any of them add up to 15. So 1 plus 36, that equals 37, so that's not it. I have 2 plus 18, that equals 20, that's not it. And I have 3 plus 12, so that equals 15, so this is it right here, right? That was what I was wanting to have happen. So now that I've found my two numbers, I'm gonna go ahead and write them here, 3 and 12. And the next thing I'm going to do is I'm going to, instead of having, so my next step is instead of having 4x squared plus 15x plus 9 equals 0, I'm going to replace my 15, which is my B, right? Remember that this is B. This was A times C. I'm going to replace my B by writing it as the sum of 3 and 12, those two numbers that I found. So I'm going to have 4x squared plus 3 plus 12x, right? So just splitting it up into those two numbers that I found earlier. Then I still have plus 9 equals 0. And so what I'll do here, I'm going to give distribute the x onto the 3 and the 12. So I'll have 4x squared plus 3x plus 12x plus 9 equals 0. And I can leave it as 3 then 12, or I can put it as 12 then 3. It doesn't matter. The first thing I want to do is I want to kind of look at them in little pairs. So I'm going to look at it here, and then I'm going to look at these two here. And in the first pair, I'm going to factor it just as a pair. So now I'm going to factor this. Meaning I'm just going to pull out what's common. So if I have 4x squared and 3x, the only thing that I could pull out of both of these is a single x. So that's going to give me x times 4x plus 3. So that was the first pair, plus, now I look at my 12x and my 9, and I think, what's common? What can I pull out from both of these? And I could pull out a 3. So if I pull out a 3 from 12x, that will leave me with 4x. And if I pull out a 3 from 9, that will leave me with 3. Still equal to 0. But now notice that I can again factor out. There's 4x plus 3 is now present in both terms. So I'm going to factor out this 4x plus 3. And when I pull that out, what I'm left with is x plus 3. So now I have factored my quadratic equation. So this is the factorization. Let's talk about what the solution is, because the factorization isn't the solution, but we're about there, right? So because of the zero property rule, if 4x plus 3 times x plus 3, that equals 0, this means that either 4x plus 3 equals 0 or x plus 3 equals 0. So let's see if we can figure out an x that will satisfy. So we've got 4x plus 3 equals 0. I'm going to solve this for x. So that gives me 4x equals negative 3 and x equals negative 3 over 4. Or I could also have x plus 3 equals 0, which just gives me x equals negative 3. So the solutions that we get for our problem are precisely x equals negative 3/4, x equals negative 3. So the question statement was use grouping to factor, which we did, and solve, which we did. So the factorization is just where we split it into two terms multiplied together. And the solution is when we take those two terms and solve them independently for 0, set them to 0 and solve it. So let's also look at the solution just graphically. We haven't really gotten to graphing parabolas yet, but just as a sneak peek, we notice here that x equals negative 3/4 is right here. It's where the parabola crosses the x-axis. And we also have x equals negative 3. So these numbers are exactly where the parabola crosses the x-axis. So we could solve this graphically, we could solve it algebraically. We're always going to get the same answer. So let's try another example with the same method. So remember that we have ax squared plus bx plus c equals 0. Let's take a minute to think about this really quick. What if we had been given 12x squared equals negative 11x minus 2 and been asked to solve that? That's totally fine. We would just move everything back over to one side of the equation and transform it into that. So this is, regardless of how your quadratic is given to you, you want to transform it back into the standard form and then from there go into your AC method. So this is telling us that A is equal to 12, B is equal to 11, and C is equal to 2. So if I have my AC method, right? So A times C goes in the top, so 12 times 2, which gives me 24. And then in the bottom, I get B, which is 11. And I'm looking for two numbers that are going to multiply to 24. And that add to 11. So I could definitely do 1 and 24. I could do 2 and 12. I could do 3 and 8. I could do 4 and 6. I can't do 5 or 7. And then the next number is 8. So that'll put me, we already have an 8 here, so that'll just put me back down this track and I'll be rewriting stuff. So let's check that if any of these add to 11. So I have 1 plus 24, which equals 25, not going to work. 2 plus 12, which equals 14, not going to work. 3 plus 8, which equals 11. I'm good. I found it. I don't even need to check the others, but if I did, I would see that 4 plus 6 equals 10. Doesn't work. So here I have 3 and 8. So again, it does not matter if you put a 3 and an 8 or then an 8 and a 3. It'll work out the same either way. So we want to take this 3 and the 8 and we want to write it in lieu of 11. So remember that 11 is B. So we want to use the 3 and the 8 here to represent B. So our original was 12x squared plus 11x plus 2 equals 0. And I'm going to rewrite 11 as the sum of 3 and 8. So I'm going to have 12x squared plus 3 plus 8x plus 2 equals 0. So again, that 3 and that 8 are what we had to bring us to 11. Then I'm going to give each of them their own x through distribution. So it's really 3x plus 8x. And then I'm going to pair them up, the first two and the last two. And I'm going to look at the first two. I'm going to say, what's the most I can factor this? I can definitely pull out an x, but I can also pull out a 3 as well, because 3 goes evenly into 12 4 times. So this will give me 3x times 4x plus 1. So just to double check, 3x times 4x gives me 12x squared, and 3x times 1 gives me 3x. Next, I just copy the sign that I have here, and I need to look at the pair of 8x and 2. So the biggest thing I could pull out of them is going to be a 2. So if I factor out a 2, that'll leave me with 4x plus 1. And if you've done your AC method correctly, you will have the same term in both. So if I, for some reason, let's say I had a 2 here instead, that would be a tip off that something's gone really wrong, because I need them to match or else I can't continue. So now what I can do is I can actually pull out this 4x plus 1 from each of these terms. So I'm going to pull this out as a factorization. So that gives me 4x plus 1. And it was clinging to a 3x. And it was clinging to a 2. So this is my new factorization. So just to be clear, what we've accomplished so far is just the factorization. We have not solved it. So this is only the factorization. But now I want the solution. So the solution comes from the zero product. So if 4x plus 1 times 3x plus 2 equals 0, then either 4x plus 1 equals 0 or 3x plus 2 would have to equal 0. And so now we're going to solve both of these equations, and that's going to give us the solution to the quadratic. So if we solve, I'll have 4x plus 1 equals 0, and I have 3x plus 2 equals 0. So I'm going to subtract 1 from both sides. That gives me 4x equals -1. I'm going to divide by 4 on both sides. And so I get that x equals -1/4. Similarly over here, I'll subtract 2 from both sides, which gives me 3x equals -2. And then I'll divide by 3. So that x equals -2/3. And so now these are my solutions here. So the next thing that we can do in order to solve a quadratic equation is we can use the square root property. So the square root property can be used when we don't have a linear term, right? So we just saw that our equations were ax squared plus bx plus c equals 0. That was our standard form. And this guy whose power is 1, this is our linear term. If our linear term is 0, then we would just have ax squared plus c equals 0. And this is the kind of equation that we can solve using the square root property. So the square root property here in the gray box says that if x squared equals k, then taking the positive and negative square root will be a solution for that. So let's do some examples to see how that all works out. So in this first case, we are already isolated. So this is kind of like a halfway worked out problem for us. So the idea is that you just want to take x squared equals 8. Then you want to square root both sides. So the square root of x squared equals the square root of 8. If I square root the square, then that's fine. I'm going to get x. It's actually the absolute value of x, but let's not tell anyone right now. And then I'll get plus or minus the square root of 8. I can simplify the square root of 8. So here's how. So we know that the square root of 8, I can write 8 as 4 times 2. And I also know that square roots play nicely with multiplication. So I can write this as the square root of 4 times the square root of 2. So we saw this last lecture in 2.4. The square root of 4 is going to give me 2, and the square root of 2 is going to do nothing. So now I get 2 root 2. So here for my answers, I'm going to get x equals plus or minus 2 root 2. So that is to say, if I'm looking at a solution to the equation, x squared equals 8, here's how I would write it out in a full sentence. So both of those, the negative and the positive version, they're both solutions to the quadratic equation.